Hello everyone, this is the video for Worksheet D in Unit 4. On this one we're going to be talking about double angle and half angle identities. All of these identities are on that notes filled in sheet that everything's been on so far. But yeah, if you still haven't looked at those identities and written them down, make sure you do so because everything we've been doing has been coming off that sheet. So before we get into Worksheet D, I did get a question about Worksheet C, the last two problems on there, number 13 and 14. Number 13 and 14 say verify that each equation is an identity. So this is basically the same thing you were doing on Worksheet B, but you're using those sum and difference identities that we had on Worksheet C to kind of help with these, and I'll show you what I mean. So looking at the two problems, here they are. For the first one, we're looking at 13. You can't do anything on the left side at all because there's just really nothing to do there. So the side we're going to have to start with is the right side. So we're going to convert those tangents. One's of x and the other one is of y. So if we convert those, we're going to get sine of x over cosine of x and sine of y over cosine of y. And just replace those like we have been. The one out front we don't really do much with until we get the fraction in simplest form. So those two fractions are multiplying, so multiply tops, multiply bottoms. This is what you get. Then that one I'm going to turn into the same thing that's on the bottom of that fraction that we just made. So I'm going to call it cosine of x times cosine of y over cosine of x over times cosine of y. That's so that the bottoms of those two match, and now you can subtract them. So if we subtract those, we get this huge mess, and this truly is a bunch of stuff going on. It's kind of a mess. Right here, you might get stuck, and that thing on top might look familiar. Well, if you go to your identity sheet, and what we did on Worksheet C was these sum and difference identities, well, the top of that is cosine of x times cosine of y minus sine of x times sine of y. And if we just look for something like that, it looks a heck of a lot like the very first one there, where it says cosine of alpha plus beta. Well, the alpha and betas in this case are x's and y's. So all of the stuff we have on top of that is going to get replaced with cosine of x plus y. So that's what we're replacing here. So that whole top thing just becomes this. And that's all based off of that identity sheet. That looks exactly like what we started with. So therefore, we just write a big check mark. We write QED, and we're all done with that one. So that one definitely had a trick to it. But if you recognized that that was a sum, then you would have gotten it. Okay. Number 14 is real similar. On the left side, we have sine of x minus y minus sine of y minus x. So we're going to look on our identity sheet to figure out what those difference identities are. On the right side, there's a whole bunch of rough stuff over there to deal with. So we're going to ignore that side for now. We're just going to tackle the left side. So the sine of x minus y, if we look on our sheet, sine of, on the sheet it says alpha minus beta, but we replace that with x minus y. And we're going to get all of this stuff. And then we do the exact same trick for the sine of y minus x, and you're going to get all of this stuff. Now you have to be very mindful of that negative out front. That's why I put the second bit of stuff in parentheses, because I wanted to remind myself to distribute that negative upon both of those. So after we distribute the negative, first one switches from positive to negative, second one switches from negative to positive. We get this. And then from here, you just have to be very cognizant of sine of x times cosine of y is the same thing as cosine of y times sine of x. So we have a lot of things here that are the same. They're just written in different orders. So for the first part, sine of x times cosine of y and cosine of y times sine of x, those two are the exact same thing. They're just written opposite. So we can combine those since they're the same thing. And since there's two of them, they're adding them. We put a 2 out front because it's basically that doubled. And then the 2 in the middle match as well. It's cosine of y times cosine of x times sine of y. And they're both negative, so those two are going to combine to make negative 2 of those. So 2 times that one and the negative 2 times that one, and that looks identical to what we started with, so we put check mark and write QED. So those problems, not super hard if you can recognize those identities, but that's the whole trick to them. So if you got stuck on those, don't feel bad because they were pretty tough. All right, so let's switch gears and let's talk about Worksheet D. So on the top of this, we have they're asking us to use double angle identities, and we have to do it for sine of 120, cosine of 120, and tangent of 120. Well, if we look at our sheet at the double angle identities, we got a single one for sine, a single one for tangent, so those ones, we're always going to use those. And then cosine, they give us 3 different versions. It doesn't matter which version you use, you should get the same thing every time. So it's kind of up to you what you want to pick, what you want to deal with. If you hate converting one into a fraction and all that stuff, then maybe you avoid the second two. So it's kind of up to you, but just realize you have your choice with cosine and you don't with sine or tangent. So for example 1, we have sine of 120. Basically, to use the double angle identities, we have to think of some number that's doubled and gives us 120. So you could basically just cut 120 in half, and that would be 60. So instead of thinking of it as sine of 120, which we could just look up on a chart, we're going to think of it as sine of 2 times 60. So the 60 is kind of the magic number there. So we're going to go to our double angle sheet, and it says sine of 2 times some number equals all that stuff on the right. So once you get the 2 times 60, you rewrite it like this. So it's going to be 2 times sine of 60 times cosine of 60. Well, the sine of 60 and cosine of 60 are just things we can look up on our chart, our like a unit circle chart. So that's what I did. I pulled this, and we get square root of 3 over 2 and 1/2. So we replace those, and those get stuck in right there and there. Now everything's multiplying here. 2's cancel off on one of them, so we're going to get square root of 3 over 2. And if you weren't sure if that was true, we could have done this at the very beginning just by looking up on a chart. So the very beginning said, what's the sine of 120? Well, if you go to the chart, sine of 120 is square root of 3 over 2. That's what we got. So we know we did it right. You won't be able to do that every time, but on these basic ones, you can, because you can look them up. They're not hard. Okay. So now let's do cosine. Cosine of 120. Like I said, you have your choice on this one, on which of those 3 you want to use. It really doesn't matter which one you pick. So once again, we're going to bust cosine of 120 into 2 times 60. 60 is kind of the magic number there. Which one did I use? I think I used the first one. So I did cosine squared of 60 minus sine squared of 60. So I'm going to use that top one. Okay. So on the next step, my cosine of 2 times 60 is the same thing as cosine squared of 60 minus sine squared of 60. And now the way you treat those is you don't square anything until you have an answer. So we're going to look up cosine of 60, whatever that is. Let's say it's 1/2. That's what we're going to square. Same thing with the sine squared of 60. We look up sine of 60 and then we square it. So clearing up some confusion on that. So we look up cosine of 60, we get 1/2. We look up sine of 60, we get square root of 3 over 2. So we plug those in. And now, like I said, I toss those in parentheses so you can see that that's what we're squaring. And don't forget, when you square a fraction, you square the top and the bottom separately. So the first one's going to be 1 squared is 1, 2 squared is 4, so I get 1/4. The second one, square root of 3 squared, is just 3, and then 2 squared is 4. We're going to subtract those 2 fractions, and up top we're going to get negative 2 over 4. Negative 2 over 4 reduces to negative 1/2. And if you didn't believe me, you just look up cosine of 120. Cosine of 20 is negative 1/2, just like we got. So, yay, math works. Okay. Let's look up our last one on that little part is cosine of 120. I'm sorry, not cosine, it's tangent of 120. Once again, we're going to do the same trick. Tangent of 2 times 60. 60 is what we're going to be using. So this is the formula off of our sheet. Take the x's in this case, we're going to be all 60s. So tangent of 2 times 60 is all that stuff over there on the right. Now this one gets a little more algebra involved, but it's the same basic process. Look up tangent of 60, and you're going to get square root of 3. So all those get replaced with square root of 3. On the top, we just get 2 times square root of 3. On the bottom, we get 1 minus 3 because square root of 3 squared is just 3. And then from there, we're going to get 2 root 3 over negative 2. 2's cancel off, and you just get left with negative square root of 3. Look that up on a chart, and yep, that's what we were supposed to get. So everything worked. Okay, so that's the first bit, and it's basically just saying, you know, figure out what the tangent or sine or cosine of this angle is. And for our purposes, everything was on the chart so we could check our answer. A lot of times, well, I'd say most times, they're not going to be on the chart, and that's kind of the purpose of this, is finding the exact measure of a trig function that we don't have on the chart already, so something more exotic, and you'll see what we're talking about with the next ones. Okay, so example 2 says you're going to use the half angle identity. So we look back at our sheets, and for this one we have 1 to use for sine, we have 1 to use for cosine, and now we have our choice of 3 for tangent. I don't know, that first one for tangent looks rough. I mean, we could use it, but that's not the one I picked, I don't think. So I'll show you what I used when we got to it. So there's 6 of these. I started with this one. Now this one is in radians, and so what we have to do is think of some number that when you cut it in half, you get 1/8 of a pi. Well, if you really wanted, if you just had no idea, you could just double this, and you could get it that way, because you know, you cut it in half, you get the same thing. So if you double 1/8 of a pi, so let's say you have a piece of pie, and you cut 1/8 of it, one slice. If you double that, you're going to have 2/8. 2 over 8 reduces to 1/4, or a quarter of the pie, and that's what I have on top. Okay, and you can think about it like this with this picture. Okay, so we have our magic number is going to be pi over 4, and that's what we're going to be plugging into the formula. Well, for cosine, we only had one choice, so this is what it looks like when you plug it in. Pi over 4, cosine of pi over 4 is just something we can look up. So we go on our chart. Cosine of pi over 4 is going to be square root of 2 over 2, and it's positive, so that's nice. So this is what you end up getting when you do that. So from here, it's just reducing algebraically. Up top, we have that 1 plus that fraction, so we have to make that fraction match. So we turn 1 into a fraction that's nice, which I use 2 over 2. Add the tops, keep the bottom the same, so we get this. Now I have fraction divided by 2, so I'm going to turn that 2 into a fraction, so we get fraction divided by fraction, which is always what we want. Then we do keep, change, flip, and all this is still under that radical sign. Okay, so from here we're going to multiply the tops, multiply the bottoms, and you end up with this, and this is okay. And now I'm going to take the square root of the top and the square root of the bottom separately, which is totally allowable. You can do that. So on top, you're going to be left with that, and the way I got that 2 on the bottom is the square root of 4 on the bottom turns into a 2, so the radical is missing from the bottom, and that's good because that's what you want. So this is where I'm going to stop. I don't need to go any further. If you were doubtful that you got this right, let's say you did a bunch of algebra and you got something screwy at the end, and you just wanted to check it, what you could do is just plug this into a calculator, and you get some decimals, and at the very beginning of the problem, just plug in I think it was cosine of pi divided by 8. Make sure your calculator is in radians. You can do it that way. Okay. So yeah, this is an exact answer, and it's right. Okay. So now let's do the next one. We got sine of negative 22.5. So remember, with negative angles, that's just going the opposite direction on our unit circle. So it's really, there's really a positive angle that corresponds with that, but we'll just be clever about it when we plug that in. So what number doubled what number cut in half is negative 22.5? Well, that's going to be negative 45 degrees. So negative 45 is our magic number. So I look on my sheet. Sine only has one choice as to what to use for our half angle identity. So all those x's in there are going to be replaced with negative 45 degrees. So plug them in, and it looks like that. I look on my unit circle, and I got to be very, very careful when I look on my unit circle because I'm going to start at the beginning. I'm going to go down 45 degrees. So it's really the same thing as, oh god, I want to get this right, positive 325 degrees? No, 315 degrees, I think what it was. So when you look that up on your chart, you're going to get square root of 2 over 2, and that's for cosine, and it is positive because that's the x portion. So this is what you end up with. From there, we're going to do the same trick. We're going to turn that 1 to 2 over 2, subtract the tops, keep the bottom the same, make the bottom a fraction, and then do keep, change, flip, multiply the tops, multiply the bottoms, and then we're going to square root the top and bottom, and you're going to end up with that. So very, very similar answer, real similar process, but yeah, this is for sine now, okay? If you want to take a pause and try the next one on your own, you're going to basically be doing the same exact thing. You're going to get a real similar answer at the end. But yeah, if you want to take a pause here and then try this one on your own, see how you're doing, go ahead. Okay, so let's go over sine of 5 pi over 6. So we think of what number cut in half is this. If we don't know that, like I said, we just double it. So here's my work on doubling this. I just multiplied it by 2. The 2 just multiplies the top, not the bottom, so we get 10 pi over 6. 10 pi over 6 reduces to 5 pi over 3, and that's almost 2 trips around this, the unit circle. It's real close, but it's not quite. So if we, well, we're going to use 5 pi over 3 in terms of our half angle identity. So once again, sine only has one option, and that's the one we're going to use. So when I plug that in, I replace all the x's with 5 pi over 3, and this is what you end up with on the right side. Now, I find 5 pi over 3 for cosine on my chart, and that is all the way at the bottom, and it gives us, what is it, a half, I think? Yeah, it gives us a half, so that's what we plug in. So this one's going to be nice and easy. We won't have very many radicals to deal with. So 1 minus a half is a positive half divided by 2. If you cut a half a pizza in half, you're going to be ending up with quarters of a pizza, 2 quarters. And then square root at the top, square root at the bottom. Square root of 1 is 1, square root of 4 is a 2. And so you end up with plus or minus 1/2. And that's our answer. Okay. Once again, if you want to pause it for cosine of 75 degrees, give it a shot. Feel free, and then start it up again, and then I'll go over the answer. Okay, so cosine of 75 degrees. Well, what number cut in half is going to be 75? Well, if we don't know, we just double it, and you're going to get 150. Take that 150, and we come to our chart, and we see that the only option is this this one right here in the middle. So we replace that x with 150, and this is what we get. We look up cosine of 150 on our chart, and we end up with a negative square root of 3 over 2. So this one's going to be a little more of a mess, but we can deal with it. That 1 becomes 2 over 2. Subtract the tops, keep the bottom the same. I made the bottom already 2 over 1, so I skipped a step there, but that's what you end up with. Do keep, change, flip, you end up with this. Multiply the tops, and you end up with this. Now square root the top and the bottom, and you'll end up with this. Now square root of 4 just turns into a 2. So this is your final answer on that one. Okay, now let's talk about the tangent ones. The tangent ones, you have a choice of 3 to use on this one. Like I said, using any of them will get you to the same spot, so it doesn't really matter which one you choose. I think some of them are easier to use, but really it's a preference thing. So just look at each of them and say, oh, I don't like that one, I do like this one, and pick what you want. So we have a negative 12th of a pie. So you can think of a whole pie cut into 12 slices. This is one of them, and it's going in the negative direction. So negative 1/6 is how you get that, cut that in half, and that would be a 12th. So that's the number we're going to use. We come down here, and I didn't like the first one because it has a radical. So I forget which one I used, either the one on the right or the one below the radical. So, oh yeah, I used the one on the bottom. So I'm going to use sine of x over 1 plus cosine of x, and the x's are all going to get replaced with negative pi over 6. So I plug those in, and I'm going to look up negative pi over 6. Well, negative pi over 6 is the same thing as, what the hell is it? 11? 6? Let me think about this. Yeah, I want to be right. Because 12/6 would be a full trip, so it's the same thing as positive 11 pi over 6. Yeah, that's right. So that's how I got that off my chart. If you're looking at a unit circle, you're just swinging down 1/6 of a pi. So it's really, really close to the beginning, but we're going in the negative direction. So if you look up these correctly, you should get square root of 3 over 2 and 1 plus square root of 3 over 2. Okay, and then we get this. We turn that 1 into 2 over 2. And if that's true, then you're going to get, let me make sure I'm right. Cosine, okay. All right, so yeah, we get this. On top, well, we turn the bottom into a fraction, and we have this. So we do keep change flip, and we get this. And now we're going to multiply. Well, the 2's are going to cancel off, and we're going to get, let's see. We're going to get those to cancel off, and so we get this. We can't have a radical on the bottom of our fraction, so we multiply it by the conjugate of the bottom. And if we do that, we should end up with this. And you can FOIL that, and you should end up with this. And then on the bottom, we get a 1. So everything on the top is just that's gonna be our answer. So our final answer should be 2 root 3 minus 3. So that's what we should get for an answer. Okay. Now, if you want to pause the video and try negative 22.5 tangent on your own, go ahead. If not, just wait for me and we'll get going. All right, so tangent of negative 22.5 is the same thing as tangent of negative 45 cut in half. So we come on here. I'm going to use the same exact version of tangent that I used on the prior problem because it's easier. So sine of negative 45 plus 1 of cosine of negative 45. If we look down here, that negative 45 is the same thing as positive 315. So we're going to get root 2 over 2 and negative root 2 over 2. So this is what we end up with. We make that 1 into 2 over 2. Combine the 2 on the bottom, we end up with this. So we're going to do keep change flip. And the 2's will cancel off again. We'll get this to happen. And now we can't have that radical on the bottom, so to make that disappear, we multiply by the conjugate on the bottom. So 2 minus the square root of 2. And you should end up with this. And now the bottom is just going to become a 2. This is really, really close to done. If you left it like this, it wouldn't be the end of the world, but it can be reduced one more step. Break that into both fractions, so you can divide each fraction by 2 separately. The 2's cancel off on the first one, and then 2 divided by 2 is just 1. In our case, it's negative 1. So this is what you get for a final answer. Okay? All right. The next two problems, you're going to be drawing a couple pictures. So these are like past problems we've done where we have to draw a triangle and then figure out the missing side and then just kind of use that to help us. So this one says find the half angle of sine given that the sine of just angle A is 3/5. And then they tell us where to draw the triangle. So they say the triangle is in between half a pi and a full pi. So that's in quadrant 2. So when I draw that picture, it should look like this. So this is all the information they've given me. Pi over 2 is 90 degrees, and then pi is 180 degrees. So we know that's how I know where to draw it. Sine of A, sine of angle is opposite over hypotenuse, so 3 divided by 5. So it has to look like this orientation and everything. So all we're going to do is find that missing side. So we're going to use, if you know your Pythagorean triples, you probably know this one. This is one of the easier ones. If you don't use Pythagorean theorem, we're going to get 5 squared equals 3 squared plus b squared. Do all the work, and we're going to find out that the missing side is 4. So we come back and write the 4 there. So now it says at the very beginning, find sine of a divided by 2. So we're going to come over to our sheet, and instead of it being a over 2 on our sheet, it's x over 2. So we're going to use this formula right here. Okay. there's nothing really special about this, but we're going to use everything on the right side there. So sine of a divided by 2 is this, and I just copied this straight off the sheet so far, so nothing magical has happened yet. Now the cosine of a is the reason I had to draw this picture. So cosine of a, I come back over to my picture, and cosine of a is adjacent over hypotenuse. Well, in this case, the adjacent side to that a, angle A, is 4, and the hypotenuse to that angle A is 5, so we're going to get 4/5. So we're going to get cosine of A in this situation is just 4/5 because it's adjacent over hypotenuse. So that's how I end up with this. Now from here, it's just reducing this with clever algebra, so that 1 is, well, if you have a whole pizza and you take 4/5 of it away, you're going to be left with a 1/5. We're going to cut that in half. Half of a 1/5 is a 1/10. And then we're just going to square root the top and bottom. Square root of 1 is just 1. Root 10 is just root 10. We can't have a radical on the bottom, so I multiply by root 10 over root 10. We end up with 1 root 10, or just root 10, over a regular 10, and it should be plus or minus still. Okay? Kind of a tricky problem, but this next one is really, really similar, so if you want to give it a pause and see if you can't do it on your own, go ahead. If not, just hang tight and we will go over it. Okay, so first things first, let's draw a picture. Once again, this is going to be quadrant 2 because it's in between half a pi and a full pi. So this is what I get from my initial picture. They said sine was 1/3, so opposite of a is 1, and then our hypotenuse is 3, so we get the 1 right there and the 3 right there. We use Pythagorean theorem to come up with the third side. This one doesn't come out to a nice, neat number. This one kind of comes out to an ugly number, so it's going to be 2 root 2. So we write that over here, and now we're just going to do the same exact process. So at the beginning, they asked for cosine of a divided by 2. We come over here, and we find cosine of x over 2 is all that. So we're going to write that on our paper first. And then cosine of a, well, we come back to the triangle. A is adjacent over hypotenuse, so 2 root 2 over 3. And that's how I end up with 2 root 2 over 3 for the cosine of a. Okay, from here, the algebra on this is going to suck a lot more, but we're going to do it the same. We're going to get 3 over 3, add the tops, keep the bottom the same, turn the bottom into a fraction, keep change flip. We get this. There's nothing we can reduce, which sucks, but that's what we got. So we get this. Now, if you left it like this, that'd be okay. This is a pretty good answer, to be fair. But that 6 on bottom, we can divide both things on top separately. So that's what I did here. 3 over 6 is just going to reduce to a half. And then that's 2 root 2 over 6. The 2 and the 6 are going to reduce to 1/3. So we're going to end up with this. There's nowhere further to go on this, so we're just going to leave it like this. Yeah, like I said, that's the best answer you could have. Now, this is it for the example problems. All the problems on here are pretty similar. Number 1 through 3, it just says find all the expressions using double angles. So those are going to be super duper similar to the first 3 we did. Number 4 through 6, it says use the half angle. So that's really similar to the middle 6 that we just did. And then 7 through 12, you're going to be using the identities that we talked about. So you're going to look at each of them and see if you can't, identify something that looks familiar and then make it turn into something else. So, and then on these, all you're doing is simplifying. So this isn't like proving any identities or anything like that. If you have any questions on this, let me know and I'll address it in the next video. And then down at the bottom, you are doing some verification. So like on 13, you're going to try and make the left side look like the right side, I guess. And then on 14, I would definitely start with the right side. Oh, God, that one's hard. So, yeah, give those a shot. Those, I don't know, those are really tough. I would do tangent squared of x divided by 2. That's a half angle theorem, so I would figure out how to deal with that squared and go from there. Okay, those are not easy problems, the last 2, so if you get everything except these, that's not a problem. There's not going to be anything that hard on the test. So yeah, give those a shot, and I will make another video, gosh, probably by Tuesday this week coming up. I'm making this video right now. I think it's, what day is it? It's it's April 4th. So it's Saturday. So I'll make the next video probably tomorrow or on Monday, and then I'll post that. So like I said, if you get stuck, have any questions, email me. And what else do I have here? Yeah, you're going to use these double angles and half angles identities all over this worksheet, so make sure you have those filled in. And then, oh yeah, here's a picture of all the work that I had on all of these. So like I said, this is going to use a ton of paper, so don't feel bad if you're going through the worksheets and stuff and you're just using tons of paper. That's fine. And that is it. So work on that. Like I said, any questions, give me an email. All right, see you soon. Wash your hands.